Now, in this lecture, we'll answer on two questions. In the first question, we'll find out the radius of this quarter circle, and in the second question, we'll find out the size of this angle theta, that is inside triangle ABC. So, we'll start with the first question. In the drawing, we have a quarter circle. The side BC, or line segment BC, equals to 9 units. Line segment CD equals to 16 units. And line segment DL equals to 12 units. And we know that this angle OBC equals to 90 degrees. This angle BCD also equals to 90 degrees. And this angle CDL, it is also equals to 90 degrees. And our mission is to find out the radius of this quarter circle. So because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle. So I'll write it down that point O is the center of the quarter circle. Point O is the center of the quarter circle, and angle BOF, this angle, it is equal to 90 degrees. And also side AO, it is equal to side OF, and both sides are the radii of this quarter circle. So we'll define the radius of this quarter circle as R. Therefore, OF, that is actually the radius of the quarter circle, it will be also equal to R, according to our definition. Okay. In the next step, we will do a construction. We will extend the straight line CD by a straight line. Okay, we extended the straight line CD by a straight line. By extending the straight line CD by a straight line, here, first of all, we will define the touching point of the extended straight line CD and the radius OF as M. Actually, by extending the straight line CD, here we created quadrilateral BCOM. I write it down. We have here quadrilateral BCOM. And in quadrilateral BCOM, we have 1, 2, 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO, this angle. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle, angle DMO, is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. So I found out that the missing angle, it is a right angle. So this angle equals to 90 degrees. So actually, inside quadrilateral BCOM, we have four right angles. And any quadrilateral that has four right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral BCOM as a rectangle. I repeat again, quadrilateral BCOM is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So therefore, in rectangle BCOM, side BC must be equal to side OM. I'll write it down. In rectangle BCOM, side BC must be equal to side OM, according to the rule that the opposite sides of a rectangle are equal to each other. But it is given us in the question that side BC equals to 9 units. So we can write here that BC equals to 9 units. And from this equation, 9 equals to BC equals to OM, we will derive that side OM is also equals to 9 units. Side OM equals to 9 units. So we can write here that OM equals to 9 units. Here we know that CD, it is a straight line, according to what is given us in the question. And when we extended the straight line CD, we created line segment CM. When you extend a straight line by a straight line, the result must be a straight line. So when we extended CD by a straight line, the result is CM. Therefore, CM must be a straight line. Okay, CM must be a straight line. I will write it down. Line segment CM is a straight line. And if we focus on this side of the straight line OC at point D, which angles we have? At point D on this side of CM, we have this angle that is equal to 90 degrees, plus this angle that is actually angle MDL, In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. Here, CD is the straight line, so in the upper side of the straight line, CD at point O, alpha plus beta equals to 180 degrees. So according to this rule, we get that if we focus on this side of the straight line CM at point D, the sum of the angles here must be equal to 180 degrees. That is to say, 90 degrees plus the size of angle MDL, in total they must be equal to 180 degrees. Here we subtract 90 degrees from this equation and we get that the missing angle MDL equals to 180 degrees minus 90 degrees. It is equal to 90 degrees. That is to say, it is a right angle. So this angle equals to 90 degrees, angle MDL. It is a right angle. Likewise, OM equals to R. It is the radius of the quarter circle. OM equals to R. Therefore, we can conclude from it that OM, it is absolutely a straight line. It's the radius of the quarter circle. OM is a straight line. OM is a straight line. So, if we focus on the upper side of this, actually, here, OF is the radius of the quarter circle that is equal to R. Therefore, OF is the radius of the quarter circle. It is a straight line. Here, OF equals to R. It is the radius of the quarter circle. Therefore, OF is a straight line. Therefore, OF is the radius of the quarter circle. It must be a straight line, of course. Here, OF is a straight line. And here, if we focus on the upper side of the straight line OF at point M, then the sum of the angles here must be equal to 180 degrees. Okay, so in the upper side of the straight line ON at point M, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of OF at point M? We have here 90 degrees plus this angle that is actually angle DMF. In total, the sum of those two angles must be equal to 180 degrees, according to rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. I repeat again. On the upper side of the straight line OF at point M, the sum of the angles must be equal to 180 degrees, that is to say 90 degrees plus angle DMF. In total, they must be equal to 180 degrees. We subtract 90 degrees from this equation and we get that the missing angle DMF is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. So we found out that the missing angle, it is a right angle, it is equal to 90 degrees. Here, this angle equals to 90 degrees, it is a right angle. In the next step, we'll focus on point L, and from point L, we'll draw perpendicular on the radius OF. I repeat again, from point L, we'll draw perpendicular on the radius OF. So actually, this angle equals to 90 degrees according to our construction, because we draw perpendicular from point L. We define the touching point of the perpendicular from point L and the radius OF as point N. So you can see from the drawing, points N and F are very closer. Therefore, we can say for sure that the radius OF of this quarter circle will be very close to the value of ON, because the distance between points N and F are very, very small. Okay? But still, the radius OF, it is a little bit longer than line segment ON. Okay, so ON, it is not the radius of the quarter circle, because ON, it is a little bit smaller, shorter than the radius OF. Okay? So, by doing this construction, we created here quadrilateral LDMN. And inside quadrilateral LDMN, we have 1, 2, 3, here, 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DLN, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle, angle DLN, is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. That is to say, it is a right angle. So this angle, it is a right angle, is equal to 90 degrees. So we actually found out that inside quadrilateral DLMN, we have 4 right angles. Okay? And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral DLMN as a rectangle. So I'll repeat again. Quadrilateral DLMN is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle DLMN, its opposite sides are equal to each other. So we define side DM of rectangle DLMN as H. Here dm equals to h according to our definition. So according to the rule that the opposite sides of a rectangle are equal to each other, we get that side dm of rectangle DLMN, side dm equals to side ln. dm equals to ln according to the rule that the opposite sides of a rectangle are equal to each other. But according to our definition, dm equals to h. So we can write here that dm equals to h. And from this equation, h equals to dm equals to ln, we will derive that side ln is also equals to h. Side ln is also equals to h. Here side ln equals to h. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, in rectangle DLMN, we get that side DL equals to side MN. According to the same rule, side DL equals to side MN. But according to what is given as the question, side DL equals to 12 units. So you can write here that DL equals to 12 units. And from this equation, 12 equals to DL equals to MN. We will derive that side MN is also equals to 12 units. Here side MN equals to 12 units. So you can see that actually the length of line segment ON, it is equal to 9 plus 12, that is 21 units. Therefore, you can see from the drawing that the radius of the quarter circle must be a little bit greater than 21 units. Why? Because points N and F are very close to each other. Okay, so we are expecting to a result that is a little bit greater than 21 units, that is the length of side ON. Okay, of the length of line segment ON. Okay. In the next step, we will join points O and C together by a straight line. So here, point O is the center of the quarter circle. Point C is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, OC is the radius of this quarter circle that is equal to R according to our definition. But OC, it is also the hypotenuse of the right triangle, the right green triangle, triangle OMC. So we will implement the Pythagoras theorem on the right green triangle, triangle OMC. And we get the first equation that will help us to get the value of the radius of the quarter circle, of course. So here, if we focus on the green right triangle, triangle OMC, in the green right triangle, triangle OMC, here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the hypotenuse is OC, therefore the square of the hypotenuse is OC squared. and it must be equals to the sum of the squares of the perpendiculars, that is to say it must be equals to OM square plus CM square. I repeat again, according to the Pythagoras theorem, in the right triangle, triangle OMC, OC square must be equal to OM square plus CM square. So here we found out that OC is the radius of the quarter circle that is equal to R. So if OC equals to R, then OC square is R square. That is equal to OM square. OM equals to 9, therefore OM square is 9 square, that is 81, plus CM square. What is the length of side CM? CM, in the drawing it is very easy to see that CM equals to CD plus DM. Again, CM equals to CD plus DM. That is to say CM equals to CD, that is 16, plus DM, that is H. So in total, CM equals to 16 plus H. If CM equals to 16 plus H, it means that CM square is 16 plus H square. So according to equation number 1, I found out that R square equals to 81 plus 16 plus H square. So here R square equals to 81 plus 16 plus H square. 16 plus H square equals to 16 square, that is 256, plus H square, plus 2 times 16 times H is 32H. So in total, in conclusion, we found out that according to equation number 1, R square equals to 81 plus 256 plus H square plus 32H. Okay? So this is equation number 1. So here we can write down that R square, according to equation number 1, equals to 81 plus 256 is 337 plus H square plus 32H. It is equal to R square. So this is equation number 1. But here we have 2 variables that are missing, that are H and R, and only 1 equation, so it is impossible to solve 1 equation with 2 variables. Therefore we create the second equation for R and H. By joining points O and L by a straight line, we create another right triangle. So this is the right triangle OLN. This angle LNO equals to 90 degrees, therefore triangle LNO, it is a right triangle. The hypotenuse is LO, but LO, it is not only the hypotenuse of the right triangle OLN, but it is also the radius of the quarter circle. Why? Because point O is the center of the quarter circle, point L is the point of the quarter circle itself, and this is exactly the definition of a radius. That is to say, OL is the radius of this quarter circle, that is equal to R according to our definition. Now we will implement the Pythagoras theorem on the right orange triangle, triangle OLN. In this way we create the second equation that will be if the variables of R and H, and in this way we will have 2 equations with 2 variables that we can solve. So this will be equation number 2. According to equation number 2, Here we'll implement the Pythagoras theorem in equation in the right triangle, the right orange triangle, triangle OLN. According to the Pythagoras theorem, in the right triangle, triangle OLN, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. The square of the hypotenuse is OL squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to LN squared plus ON squared. I repeat again, in the right orange triangle, triangle OLN, according to the Pythagoras theorem, we get that OL squared equals to LN squared plus ON squared. This is equation number 2. So according to equation number 2, we get that OL squared, ON is the radius of the quarter circle that is equal to R, so OL squared will be equal to R squared. That is equal to LN squared. LN equals to H, therefore LN squared equals to H squared plus ON squared. What is the length of line segment ON? From the drawing it is very easy to see that ON equals to OM plus MN. That is to say, ON equals to OM, that is 9, plus MN, that is 12. So in conclusion, ON equals to 9 plus 12, that is 21. So ON equals to 21, therefore ON squared equals to 21 squared. In conclusion, we found out that according to equation number 2, R squared equals to H squared plus 21 squared. Here, 21 squared is 441, so we write it down. According to equation number 2, we found out that R squared equals to H squared plus 21 squared, that is 441. So actually have here two different expressions for R squared. Therefore, we create equation number 3 that states that R squared according to equation number 1 must be equal to R squared according to equation number 2. Okay? R squared according to equation number 1 must be equal to R squared according to equation number 2. So here, R squared according to equation number 1 is equal to 337 plus H squared plus 32H, while and it must be equal to R squared according to equation number 2, and R squared according to equation number 2 is H squared plus 441. So this is equation number 3. We have H squared on both sides of equation number 3. Here, therefore H squared will get cancelled. And what is left from equation number 3 after we cancelled H squared? In this side of equation number 3 we have 337 plus 32H equals to 441. So here we subtract 337 from this equation, equation number 3, and we will get that according to equation number 3, 32H equals to 441 plus 337 equals to 104. So we found out that according to equation number 3, 32H equals to 104. So here we divide equation number 3 by 32 and we get that h equals to 104 over 32. 104 over 32 is 3.25. So we found out that h equals to 3.25. Now we'll put the value of h inside equation number 2, and this way we get the radius of the quarter circle. According to equation number 2, we've only found out that h square r square equals to h square plus 441. As I already mentioned, we substitute h by 3.25 and we get the radius of the quarter circle. So here, according to equation number 2, r square equals to h square. H is 3.25, therefore h square is 3.25 square, that is 10.5625 plus 441. So in conclusion, according to equation number 2, we found out that r square equals to 441 plus 10.5625 is 451.5625. So we found out that r square equals to 451.5625. Here we take out of this equation number 2, and we get that r equals to the square root of 451.5625. That is to say, r equals to 21.25 units. Okay, so we actually found out that the radius of the quarter circle is 21.25. That is to say, it is a little bit greater than the length of line segment ON, that is actually equals to 21 units. The radius is 21.25 units. In 0.25 units is bigger than the length of line segment ON. Okay, so we finished with the first question. So here we can write down that the radius of the quarter circle equals to 21.25 units. Okay, 21.25 units. So we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in two different methods. We start with the first method. So here in the drawing we have triangle ABC. This is triangle ABC. This angle ACB equals to 40 degrees. This angle ADC equals to 80 degrees, and this is angle theta, the angle that we are looking for to find its size. So we have to find out the value of angle ABC that is equal to theta. And we also know that side AC equals to y units, side DC equals to x units, and the length of side AB is x plus y units. And our mission is to find out the size of this angle, angle theta, that is equal to angle ABC. So we'll start with the first method. In the first method, we'll do a construction. We'll extend side BC by a straight line in y units. I'll repeat again. We'll extend side BC by a straight line in y units. That is to say, here. If this point is point E, then we actually extended side BC in such a way that the length of CE will be equal to Y units. So CE equals to Y according to our construction. In the next step, we will join points A and E together by a straight line. So by joining points A and E by a straight line, we created here triangle ACE. So I copy triangle ACE in a new page and we'll analyze triangle ACE. Okay. Side C equals to Y, and side AC is also equals to Y. Side C equals to Y according to our construction. So this is triangle ACE that I copied from the original drawing. As I've already mentioned before, side AC equals to side CE. So here, both sides are equal to Y, therefore they are equal to each other. That is to say, side AC equals to side CE, and they are both equal to Y, therefore they are equal to each other. So those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So this side is located in front of this angle, and this side is located in front of this angle. So those two angles that are located in front of equal sides must be equal to each other according to the rule that I mentioned. So here, this angle is angle CAE. Must be equal to this angle, this is actually angle AEC. Angle AEC. According to the rule that in front of equal angles, in front of equal sides in the triangle, there are equal angles. So if we define side CAE as alpha, side AE equals to alpha, angle CAE equals to alpha, that is to say this angle CAE equals to alpha according to our definition. Then from this equation alpha equals to CAE equals to angle AEC, we will derive that angle AEC is also equals to alpha. Here this angle is also equals to alpha. From the drawing you can see that this angle ACB equals to 40 degrees. So here I can draw the angle here in triangle ACE. This is angle ACB, and according to the drawing, angle ACB equals to 40 degrees. Angle ACB, this angle ACB equals to 40 degrees. So in the next step, I will present to you the angle, the zero angle theorem, and we will implement the zero angle theorem in triangle ACE. So what is the zero angle theorem? First of all, the exterior angle theorem is true in any triangle. So here we have triangle ABC that could be any triangle. This is triangle ABC. And triangle ABC has three angles. This is angle alpha, this is angle beta, and this is angle gamma. So actually, those three angles that are inside triangle ABC are defined as an interior angle. So I write it down. Angle alpha, beta, and gamma, they are defined as an interior angles. They are all defined as interior angles of triangle ABC. Okay, angles alpha, beta, and gamma are defined as interior angles of triangle ABC. While this angle ACD is defined as an exterior angle. So we will define angle ACD as E, and I write it down that angle E is defined as an exterior angle of triangle ABC. Why angle E is an exterior angle? Because of the fact that it is located outside triangle ABC, while angles alpha, beta, and gamma are located inside triangle ABC. Therefore, they are defined as an exterior angles. Okay, this is the logic for the names of the angles here. The logic behind the names of the angles. Okay, so here, according to the exterior angle theorem, we will get that the value of angle E, or the size of angle E, it is equal to the sum of the two interior angles that are not adjacent to it. Here, angle gamma is adjacent to angle E, and the two interior angles that are not adjacent to angle gamma are angles alpha and beta. And the sum of the two interior angles alpha and beta is alpha plus beta. So in conclusion, we found out that the size of the value of the exterior angle E equals to alpha plus beta. That is actually the sum of the two interior angles of triangle ABC that are not adjacent to the exterior angle E. Okay, so in conclusion, found out that the value of the exterior angle E is equal to alpha plus beta. Now we can implement the exterior angle theorem in our triangle ACE. Triangle ACE has two interior angles, alpha and alpha. And it also has here in the drawing one exterior angle that is actually angle ACB. And according to the exterior angle theorem, we'll get that the size or the value of the exterior angle ACB, it is equal to the sum of the two interior angles that are not adjacent to it. Here, this angle is adjacent to angle ACB, and the two other interior angles that are not adjacent to angle ACB are alpha and alpha, and the sum of alpha and alpha is alpha plus alpha. So in conclusion, we found out that angle ACB equals to alpha plus alpha. Angle ACB equals to alpha plus alpha. But here angle ACB equals to 40 degrees, so we found out that 40 degrees equals to alpha plus alpha. Here 40 degrees equals to alpha plus alpha. That is to say 40 degrees equals to 2 alpha. Here we will divide this equation by 2 and we get that alpha equals to 40 degrees over 2 is 20 degrees. So we found out that angle alpha equals to 20 degrees. Here angle alpha equals to 20 degrees. And here also angle alpha equals to 20 degrees. So actually you can write down in the original drawing that angle EAC, that is equal to alpha, it is equal to 20 degrees, and angle CEA, this angle also equals to 20 degrees according to what we have already found out. Okay. In the next step, we'll focus on this triangle ADC. In this triangle ADC, this angle equals to 80 degrees and this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So the sum of those two angles is 120 degrees. So the third angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle ADC to 180 degrees, because 60 degrees plus 120 degrees will complete the sum of the angles in this triangle ADC to 180 degrees. So this angle must be equal to 60 degrees. This angle equals to 60 degrees. In the next step, we will define side AD as A, and I will present to you the law of sines, and we will implement the law of sines in triangle ADC, and we will also implement the law of sines in this triangle ABD. So what is the law of sines? The law of sines is true in any triangle. So here we have here triangle ABC that could be any triangle. This is triangle ABC. The length of side BC is equal to A units. The length of side AC is B units. And side AB equals to C units in its length. So in this triangle ABC, that could be any triangle, we get that the following equation is true, that A over sine A equals to B over sine B, and it is equal to C over sine C. Small a, b, and c are the lengths of the sides of the triangle ABC, while capital A is the size of angle BAC, this angle, capital B is the size of angle ABC, this angle, and capital C is the size of angle ACB. So according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. And this equation is true for any triangle. Now we will implement the law of sines in triangle ADC. So this is triangle ADC. So according to the law of sines, in this triangle ADC, so I write it down, we'll implement the law of sines in triangle ADC. So according to the law of sines, we'll get that in triangle ADC, here DC over sinus 60 degrees equals to AD over sinus 40 degrees and it is equal to AC over sinus 80 degrees. Okay, so here we have DC actually here we have according to the first method it is a little bit different. Here we have triangle ADE, so I'll copy triangle ADE in a new page and we will analyze triangle ADE. This is triangle ADE. Angle DAE equals to 60 degrees plus 20 degrees, that is 80 degrees. It is given us the question that angle ADE equals to 80 degrees. So this is triangle ADE that is coming from the original drawing. What is the length of line segment DE? The length of line segment DE is DC plus CE. Again, DE equals to DC plus CE. That is to say, DE equals to DC, that is X, and CE, that is Y. In total, DC equals to X plus Y. So DC equals to X plus Y. And here this equals to X plus Y, and inside triangle ADE we have those two angles that are equal to each other, and according to the rule that in front of equal angles in the triangle there are equal sides, we get that in front of this angle we have side AE, and in front of this angle we have side DE. According to the rule that I mentioned a couple seconds ago, here AE must be equal to DE because those two sides are located in front those two equal angles. So side AE must be equal to side DE. Okay, side AE must be equal to side DE. But according to what we have already found out, side DE equals to x plus y. So from this equation, x plus y equals to DE equals to AE, we will derive that side AE is also equals to x plus y. Side AE equals to x plus y. Here, this side AE equals to x plus y. Okay. In the next step, I will copy the right triangle ABE in this page, and we will analyze triangle ABE, the big triangle ABE. No. This is triangle ABE that I copied from the original drawing. This angle equals to theta, according to what is given as the question. This angle equals to 20 degrees, according to what we have already found out. And side AB equals to x plus y, according to what is given as the question. And we have just right now found out that side AE equals to also to x plus y. And because of the fact that both those two sides are both equal to x plus y, it means that they are equal to each other. That is to say, side AB equals to side AE. Why? Because of the fact that they are equal to each other, and they are both equal to x plus y, therefore they are equal to each other. So side AB equals to side AE. And according to the rule that in front of equal sides in the triangle there are equal angles, so here in front of this side AE, we have angle theta. And in front of this side AB, we have angle that is equal to 20 degrees. So those two angles that are located in front the equal sides AB and AE must be equal to each other according to the rule that I mentioned. Okay, so we actually found out that angle theta equals to 20 degrees, and this is actually the answer to the question, that the size of angle theta is equal to 20 degrees. This angle theta is equal to 20 degrees according to the first method. So we finished in the first method. In the next step, I will present to you the second method. Okay. In the second method, we'll focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. The sum of those two angles is 80 degrees plus 40 degrees is 120 degrees. So we have two angles that the sum of them is 120 degrees. Therefore, this angle must be equal to 60 degrees because 60 degrees plus 120 degrees is 180 degrees, and therefore this angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle ADC, 280 degrees. Okay, so in the next step we'll define side AD as A. Okay, and in the next step I will present to you the law of sines, and we will implement the law of sines in triangle ADC, and then we will implement the same law in triangle ABD. So what is the law of sines? The law of sines is true in any triangle. So we have this triangle ABC, that could be any triangle. The length of side AB is C units, the length of side AC is B units, and side BC equals to A units in its length. And according to the law of sines, we get that A over sine A equals to B over sine B equals to C over sine C. I will remind you that capital A is the size of angle BAC, this angle. Capital B is the size of this angle ABC. And capital C is the size of this angle, that is actually angle ACB. And A, B, and C, the small a, B, and C are the length of the sides of the triangle ABC. Repeat again, A over sine A equals to B over sine B equals to C over sine C. Okay, then we will implement the law of sines in triangle ADC. This is triangle ADC, and we will implement the law of sines in this triangle ADC. According to the law of sines, we will get that AC over sinus 80 degrees, AC over sinus 80 degrees equals to AD over sinus 40 degrees, AD over sinus 40 degrees, and it is equal to DC over sinus 60 degrees. DC over sinus 60 degrees, so according to equation number 1, DC over sinus 60 degrees equals to AD over sinus 40 degrees, and it is equal to AC over sinus 80 degrees. Here, DC equals to X, so substitute DC by X. AC equals to Y, we substitute AC by Y. And AD equals to A, so we substitute AD by A. We'll do it now, and we'll get that according to equation number 1. As I already mentioned, DC equals to X, so we substitute this by X, so it is X over sinus 60 degrees. And it is equal to AD, AD equals to A, we'll substitute AD by A. So it is A over sinus 40 degrees. And it is equal to AC. Here, AC equals to Y, so we substitute AC by Y. So it is AC is Y over sinus 80 degrees. So we have here three expressions that are all equal to each other. So we will define the value of each expression as K. Therefore we can write down here that all the expressions are equal to k, and because of the fact that they are all equal to each other, you can definitely say that each expression is equal to k. Okay? So because of the fact that all the expressions here are equal to k, we will derive the first equation from this long equation, that this expression equals to k. That is to say, according to equation number 1, x over sinus 60 degrees, it is equal to k. So here we will multiply this equation number 1 by sinus 60 degrees, and we get that according to equation number 1, x equals to k times sinus 60 degrees. Okay? So here this expression also equals to k. So here this expression equals to k. So we write it down. This will be equation number 2, and the equation, according to equation number 2, a over sinus 40 degrees is equal to k Here we multiply this equation number 2 by sinus 40 degrees, and we get that according to equation number 2, a equals to k times sinus 40 degrees. And finally, this expression also equals to k. So in this way we create the further equation that y over sinus 80 degrees equals also to k. Here we multiply this equation number 3 by sinus 80 degrees, and we will get that according to equation number 3, y equals to k times sinus 80 degrees. So we actually created here 3 equations for the values of x, y, and a. Okay, so here we know that ABC is a triangle, therefore side BC is one side of triangle ABC, and so BC is a side of a triangle. It is absolutely a straight line. So you can write down that BC is a straight line. BC is the side of a triangle. It is absolutely a straight line. So if you focus on the upper side of the straight line DC at point D. Then the sum of the angles on the upper side of BC at point D must be equal to 180 degrees. So which angles we have here? On the upper side of BC at point D we have here 80 degrees plus this angle that is actually angle ADB. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so here we subtract 90 degrees from this equation and we get that the missing angle, angle ADB, equals to 180 degrees minus 80 degrees, it is equal to 100 degrees. So we found out that the missing angle, angle ADB, equals to 100 degrees. This angle equals to 100 degrees. Now we will implement the law of sines in this triangle, triangle ADB. Okay, so according to the law of sines, so I'll write it down. We'll implement the law of sines on triangle ADB. The law of sines. So according to the law of sines, in this triangle ADB, we will get that AD over sinus theta equals to AB over sinus 100 degrees. I'll repeat again. Equation number 2 is the implementation of the law of sines in this triangle, triangle AOB. According to the law of sines, AD over sinus 100 degrees equals to, again, AB over sinus 100 degrees equals to AD over sinus theta. Again, AD over sinus theta equals to AB over sinus 100 degrees. Okay. AD equals to A, therefore we'll substitute AD by A and we'll get that here A over sinus theta equals to AB equals to x plus y, so we'll substitute AB by x plus y over sinus 100 degrees. Okay. But here we have to do another step. We actually have to substitute x, y, and a by the values that we found out for x, y, and a. Okay. Here, x equals to k times sinus 60 degrees. We found out that a equals to k times sinus 40 degrees, and we found out that y equals to k times sinus 80 degrees. So we'll substitute x by k times sinus 60 degrees. In this equation number 1, x is k times sinus 60 degrees. Here actually we'll substitute a, x and y by the values that we found out for a, x and y here. Okay, so here we have a that is equal to, we already found out that a is equal to k times sinus 40 degrees over sinus theta, and it is equal to x plus y. X equals to k times sinus 60 degrees plus y, and y equals to k times sinus 80 degrees, all divided by, according to equation number 2, x plus y over sinus 100 degrees. So we have here k on both sides of equation number 2, so k will get cancelled, and what is left from equation number 2 of the cancelled k? We have here sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees divided by sinus 100 degrees. Okay. Okay, so here we'll cross multiply this equation number 2, and we'll get that according to equation number 2, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. In the next step, we will divide this equation number 2, by sinus 60 degrees plus sinus 80 degrees, and we will get that according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. So here we have trigonometric identity that states that sinus 90 degrees plus theta equals to cosine theta. We will use this trigonometric identity in order to find out the value of sinus 100 degrees. Actually, sinus 100 degrees is equal to sinus 90 degrees plus 10 degrees, and according to this trigonometric identity that sinus 90 degrees plus theta equals to cosine theta, we'll get that sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees, therefore we'll substitute sinus 100 degrees by cosine 10 degrees in equation number 2. But we have also another trigonometric identity that we will use for sinus 40 degrees. Actually, we have the trigonometric identity that states that sinus 2a equals to 2 times sine a cosine a. Okay, we'll use this trigonometric identity for sinus 40 degrees. According to this trigonometric identity, sinus 40 degrees is equal to sinus 2 times 20 degrees, and sinus 2 times 20 degrees according to this trigonometric identity will be equal to 2 times sinus 20 degrees times cosine 20 degrees. Okay, that is to say, we can substitute sinus 40 degrees. Here, sinus 40 degrees is equal to 2 times sinus 20 degrees times cosine 20 degrees. That is to say, we will substitute sinus 40 degrees by 2 sine 20 degrees times cosine 20 degrees. So, we have equation number 2 that states that sinus theta equals to sinus 40 degrees, but we just right now found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees, and according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees, and we already found out that sinus 100 degrees equals to cosine theta, so we substitute sinus 100 degrees in equation number 2. Sinus 100 degrees equals to cosine 10 degrees, so we substitute sinus 100 degrees in equation number 2 by cosine 10 degrees. And we have to divide it by sine 80 degrees times plus sine 60 degrees. Okay. So we have another trigonometric identity for sinus 80 degrees plus sinus 60 degrees. According to the following trigonometric identity, we'll get that sine D plus sine C it is equal to 2 times sine d plus c over 2 times cosine d minus c over 2. Okay, we will use this trigonometric identity for sinus 60 degrees plus sinus 80 degrees. So we get that according to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus d plus c is 80 degrees plus 60 degrees, that is 140 degrees, and 140 degrees over 2 is 70 degrees. So it is 2 times sine 70 degrees times cosine d minus c is 80 degrees minus 60 degrees is 20 degrees, and 20 degrees over 2 is 10 degrees. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. That is to say, we can substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. We'll do it now. We'll get that according to equation number 2. Sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees over sinus 80 degrees plus sinus 60 degrees, but we already found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. So in conclusion, we found out that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. Okay. Now we have the last trigonometric identity that states that sinus 90 degrees minus theta equals to cosine theta. We'll use this trigonometric identity for sinus 70 degrees. So here we'll get that sinus 70 degrees, it is actually equals to sinus 90 degrees minus 20 degrees, and actually sinus 90 degrees minus 20 degrees, according to the trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, therefore sinus 90 degrees minus 20 degrees will be equal to cosine 20 degrees. According to this trigonometric identity, so we actually found out that sinus 70 degrees is equal to cosine 20 degrees. That is to say, you can substitute sinus 70 degrees in equation number 2 by cosine 20 degrees. We will do it now, and we will get that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees, but we just right now found out that sinus 70 degrees is equal to cosine 20 degrees, therefore we substitute sinus 70 degrees by cosine 20 degrees. So here we have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled. And finally we found out that according to equation number 2, sinus theta equals to sinus 20 degrees. And we know that if sine alpha equals to sine beta, it means that alpha equals to beta. Therefore, if sine theta equals to sine 20 degrees, it means that theta equals to 20 degrees. So we found out in the second method also that the value of angle theta, or the size of angle theta, it is equal to 20 degrees. So we finished the second method. So here the value of theta is equal to 20 degrees. We finished with the second method. In the next step I will summarize the lecture. We'll start with the first question, of course. So in the drawing we have a quarter circle. We know that side ABC equals to 9 units, side CD equals to 16 units, side DL equals to 12 units. We also know that angle ABO equals to 90 degrees, angle BCD equals to 90 degrees, and this angle CDL also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. So because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle. This angle BOM equals to 90 degrees, and also side AO equals to side OF, and both sides are the radii of this quarter circle that we defined as R. Repeat again, we define the radius of this quarter circle as R, therefore side AO equals to R, and side OF it is also equals to R. They are both the radii of this quarter circle. Okay, so in the next step we extended the straight line CD by a straight line until it touches the radius OF at point M. Point M is the touching point of the extended straight line CD and the radius OF. Okay, so by doing this construction we actually created quadrilateral BCOM that has 1, 2, 3 right angles. So here in quadrilateral BCOM we have 3 right angles, and we know that the sum of 3 right angles is 90 times 3 is 270 degrees plus the size of the fourth angle. This is actually this angle. In total the sum of those 4 angles must be equal to 360 degrees. according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation. We found out that the missing angle, angle DMO, equals to 90 degrees. So this angle, angle DMO, equals to 90 degrees. So we actually found out that inside quadrilateral BCOM, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral BCOM as a rectangle. So this quadrilateral is a rectangle. And you also note that the opposite sides of a rectangle are equal to each other. So in rectangle BCOM, side BC must be equal to side OM. BC equals to OM, but according to what is given as the equation, side BC equals to 9 units. So if BC equals to 9 units, and from this equation 9 equals to BC equals to OM, we derive that side OM is also equals to 9 units. Here side OM is also equals to 9 units. Okay, then it is given as the equation that CD is a straight line. We actually did a construction. We extended the straight line CD by a straight line, and in this way we created line segment CM. And when you extend a straight line by a straight line, the result must be a straight line. Therefore, when we extended the straight line CD by a straight line and we got line segment CM, CM must be also a straight line. So here we know that line segment CM is a straight line. And we have actually rule number 1 according to rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we know that CD is a straight line. So if we focus on the upper side of the straight line CD at point O, then here, according to this rule number 3, at the upper side of the straight line CD at point O, the sum of the angles must be equal to 180 degrees. Which angles we have here? We have angle alpha plus angle beta, and the sum of those two angles must be equal to 180 degrees according to this rule number 3. We can implement rule number 3 in our drawing, because in our drawing we have here, if we focus on this side of the straight line CM at point D, then in this side of CM at point D, the sum of the angles here must be equal to 180 degrees. So which angles we have at this side, the CM at point D? We have 90 degrees plus angle LDM. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. So here, 90 degrees plus angle MDL must be equal to 180 degrees. We subtracted 90 degrees from this equation. We found out that the missing angle, angle MDL, this angle angle MDL equals to 90 degrees. Okay. So then, so we found out that this angle equals to 90 degrees. Then we focused on the radius OF. OF is the radius of the quarter circle. So OF is a radius of the quarter circle. It is absolutely a straight line. OF is a straight line, and if we focus on the upper side of the straight line OF at point M, on the upper side of OF at point M, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of OF at point M? We have here 90 degrees plus this angle, that is actually angle DMN. In total, the sum of those two angles must be equal to 180 degrees. So here, at the upper side of OM at point M, and the upper side of OF, of the straight line OF at point M, the sum of the angles must be equal to 180 degrees. So 90 degrees plus angle DMF In total, they must be equal to 180 degrees. Here we subtracted 90 degrees from this equation and we found out that the missing angle DMF, equals to 90 degrees. So this angle DMF, equals to 90 degrees. So in total we found out that those two angles are both equal to 90 degrees. Then from point L, from this point L, we draw perpendicular on the radius OF. And repeat again, from point L, we draw perpendicular on the radius OF. So this angle equals to 90 degrees according to our construction. And we define the touching point of the perpendicular from point L and OF as N. So by drawing this perpendicular, we actually created quadrilateral DLMN, and inside quadrilateral DLMN we have 1, 2, 3 right angles. I repeat again, inside quadrilateral LDMN we have 1, 2, 3 right angles. Okay, and we know that the sum of the angles in any quadrilateral is equal to 360 degrees, therefore the sum of three angles is 270 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and we found out that the missing angle DNN, equals to 90 degrees. So actually we found out that this angle equals to 90 degrees. Therefore, inside quadrilateral DLMN, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral DLMN as a rectangle. Why? Because it has 4 right angles. And we also know that the sum of the angles, the opposite sides, quadrilateral DLMN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in quadrilateral DLMN, its opposite sides are equal to each other. So here, first of all, we define side DM as H, and according to the rule that the opposite sides of a quadrilateral are equal to each other, so in quadrilateral DLMN, side DM must be equal to side LF. Side DM must be side DM must be equal to side LN. Okay, in quadrilateral DLMN, side DM must be equal to side LN. DM equals to LN, according to the rule that the opposite sides of a rectangle are equal to each other. But according to our definition, side DM equals to H. So we can write down here that DM equals to H, and for this equation, H equals to DM equals to LN, we'll derive that LN is also equals to H. Okay, so here side LN is also equals to H. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, so rectangle DLMN, side DL must be equal to side MN. Side DL must be equal to side MN, but according to what is given as the equation, side DL equals to 12 units. So we can write here that DL equals to 12. And for this equation, 12 equals to DL equals to MN, we derive that MN is also equals to 12 units. Here MN also equals to 12 units. So actually, note that ON equals to OM plus MN, that is to say ON equals to OM, that is 9, plus MN, that is 12. So in total, the length of line segment ON equals to 9 plus 12, that is 21 units. And points N and F are very close to each other, therefore the radius of the quarter circle that is equal to OF must be very close to the value of 21 units. So we are expecting to get a radius of this quarter circle that is a little bit greater than 21 units, and we can determine it according to the following, because of the fact that point N is very close to point F, and we know that ON equals to 21 units, therefore OF, the radius OF of the quarter circle must be a little bit greater than 21 units. Okay. So in the next step, we join points O and C together by a straight line. Here, point O is the center of the quarter circle. Point C is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, OC is the radius of this quarter circle, and OC it is also the hypotenuse of the right green triangle, triangle OCM. So we implemented the Pythagoras theorem on the right green triangle, triangle OCM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OM square plus CM square. Repeat again, according to the Pythagoras theorem, OC square equals to OM square plus CM square. We have already found out that OC equals to R, therefore OC square is R square. OM equals to 9 units, therefore OM square is 9 squared, that is 81, and CM equals to CD plus DM, that is to say CM equals to CD, that is 16, plus DM, that is H. So in total, CM equals to 16 plus H. So if CM equals to 16 plus H, it means that CM square equals to 16 plus H square. So in conclusion, we found out that according to equation number 1, R square equals to 81 plus 16 plus H square. Here we open the brackets on this side of equation number 1, and we found out that R square equals to 81 plus 16 plus H square. 16 plus H square equals to 16 squared, it is 256, plus H square plus 2 times 16 times H, this is 32H. So in this side of the equation we have R square, that is equal to 81 plus 256, but 81 plus 256 is 337, plus H square plus 32H. So in conclusion, we found out that according to equation number 1, R square equals to 337 plus H square plus 32H. In the next step, we join points O and L together by a straight line. By joining points O and L together by a straight line, we created the right triangle, triangle O and N. The right orange triangle, triangle O and N. So, but what is the definition of the hypotenuse ON? Point O is the center of the quarter circle. Point N is the point of the quarter circle itself. That is to say, ON is the radius of the quarter circle that is equal to R according to our definition. Now we implemented the Pythagoras theorem on the right orange triangle, triangle ON. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OL square equals to LN square plus ON square. Okay, ON square equals to LN square plus ON square. Okay, so here OL equals to R, therefore OL square equals to R square. LN, here LN equals to H, therefore LN square is H square, plus NO square. NO or ON is OM plus MN. OM is 9 and MN is 12, therefore OM plus ON is 9 plus 12, that is 21. So in conclusion, we found out that ON is 21. So if ON is 21, it means that ON square is 21 square. So in conclusion, according to equation number 2, we found out that R square equals to H square plus 21 square. 21 square is 441. So in conclusion, we found out that according to equation number 2, R square equals to H square plus 441. So we have two different expressions for R square. Equation number 1 and equation number 2. They are both the expression for R square. Okay? Therefore, we created equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. So here, R square according to equation number 1 equals to 337 plus H square plus 32H. And it must be equal to R square according to equation number 2, that is equal to H square plus 441. Okay, so here we have H square on both sides of the equation, so H square will get cancelled, and we're left only with according to equation number 3, 337 plus 32h equals to 441. Here we subtracted 337 from this equation number 3, and we found out that according to equation number 3, 32h equals to 441 minus 337 is 104. So according to equation number 2, we found out that 32h equals to 104. Here we divided this equation number 3 by 104, and we found out that h equals to 104 over 32, and 104 over 32 is 3.25 units. So we found out that h equals to 3.25 units. Now we can substitute h in equation number 2 by 3.25 units. According to equation number 2, r squared equals to h squared plus 441. And h equals to 3.25, therefore h squared will be equal to 3.25 squared. That is 10.5625. So h squared equals to 10.5625 plus 441 must be equal to r squared according to equation number 2. 441 plus 10.5625 is 451.5625. So according to equation number 2, we found out that r squared equals to 451.5625. We took a root out of this equation number 2, and found out that the radius that we are looking for of the quarter circle equals to 21.25 units. So here, as I already mentioned before, the radius of this quarter circle OF, it is a little bit greater than 21, that is the length of line segment ON, so it is greater than ON in 0.25 units. So in conclusion, we found out that the radius of this quarter circle is equal to 21.25 units. We finished with the second question, then I presented to you, we finished with the first question, then I presented to you the second question, and we solved the second question in two different methods. Okay. So in the drawing, we have triangle ABC. Here, angle ADC equals to 80 degrees, angle ACD equals to 40 degrees, side AB equals to x plus y, side AC equals to y units, and side DC equals to x units, and our mission is to find out the value of side of angle ABC that is equal to theta. Okay, so in the first method, we did the construction, we extended side BC of triangle ABC by y units. That is to say, CE equals to y units according to our construction. Then we added points A and E together by a straight line, and this way we created triangle AC. Then I copied triangle ACE in this page, and the analyzed triangle ACE. This is triangle ACE that I copied from the original drawing. Here, according to our construction, C equals to Y. According to what is given us in the question, AC also equals to Y. So both those two sides are equal to each other. Both those two sides are equal to Y, therefore they are equal to each other. So AC equals to CE. Okay, AC equals to CE. And according to the rule that in front of equal sides in the triangle there are equal angles, we get that those two angles must be equal to each other. Why? Because they are located in front of equal sides. So if one angle equals to alpha, then the other angle also equals to alpha. So both those two angles are equal to alpha. Okay. Then I copied angle ACB. Here, angle ACB, this angle ACB equals to 40 degrees. So I copied the angle here. And then I presented to you the external angle theorem, and we implemented the external angle theorem in this triangle, triangle AC. So what is the external angle theorem? The external angle theorem is true in any triangle. So we have here triangle ABC that could be any triangle. The three angles inside triangle ABC is alpha, beta, and gamma. And those three angles are defined as an interior angles. Why? Because they are located inside triangle ABC, while this angle, angle ACD, is defined as exterior angle. Why? Because it is located outside triangle ABC. So what is the value, what is the size of the exterior angle, angle E? According to the exterior angle theorem, the size of the exterior angle, angle E, or angle ACD, it will be equal to the sum of the two interior angles that are not adjacent to it. Here, this angle, angle gamma, is adjacent to angle E, and the two other interior angles that are not adjacent to it are alpha and beta, and the sum of those two angles are alpha plus beta. In conclusion, found out that the size of the exterior angle, angle E, it is equal to alpha plus beta. So according to the exterior angle theorem, the size of the exterior angle, angle E, it is equal to alpha plus beta. That is to say, it is equal to the sum of the two interior angles that are not adjacent to it. Okay, so then implemented the exterior angle theorem in this triangle, triangle ACE. In triangle ACE, we have those two angles that are both equal to alpha that are defined as an interior angles. While angle ACB is defined as an exterior angle. Why? Because it is located outside triangle ACE, and according to the exterior angle theorem, the size of this angle that is actually angle ACB is equal to the sum of the two interior angles that are not adjacent to it. Those are the two interior angles that are not adjacent to it. That is to say, angle ACB equals to alpha plus alpha. Okay, angle ACB equals to alpha plus alpha. But it is given as the question that angle ACB equals to 40 degrees. So we can write here that 40 degrees equals to alpha plus alpha. And here 40 degrees equals to alpha plus alpha. And if 40 degrees equals to alpha plus alpha, then it means that 2 alpha equals to 40 degrees. So 2 alpha equals to 40 degrees. We divided the equation by 2 and found out that alpha equals to 20 degrees. Okay, so here we have this angle that is alpha equals to 20 degrees, and this angle that is also angle alpha, it is also equals to 20 degrees. Then we focus on triangle ADE. So I copied triangle ADE in this new page and we analyze triangle ADE. This is triangle ADE that I copied from the original drawing. This angle, angle DAE, equals to 60 degrees plus 20 degrees. I explain why. First of all, this angle equals to 20 degrees. This angle equals to 40 degrees, and 80 degrees plus 40 degrees is 120 degrees. So this angle must be equal to 60 degrees in order to complete the sum of the angles in triangle ADC to 180 degrees. This angle must be equal to 60 degrees. So 60 degrees plus 20 degrees, it is equal to 80 degrees. So angle DAE equals to 80 degrees. This angle also equals to 80 degrees according to what is given as the question. And what is the length of DE? The length of line segment DE equals to DC plus EC. That is to say, DE equals to DC, that is X, plus CE, that is Y. So in total, DE equals to X plus Y. So here DE equals to X plus Y. And here we have two angles that are equal to each other. They are both equal to 80 degrees, therefore they are equal to each other. And according to the rule that in front of equal angles in the triangle, there are equal sides. So in front of this angle, we have side AE. In front of this angle, we have side DE. And according to the rule that I mentioned, side AE must be equal to side DE. Okay, but here we just right now found out that side DE equals to x plus y. Okay, so we can write down that DE equals to x plus y, and from this equation, angle and side A equals to side D equals to side xy, we derive that side AE is also equals to x plus y. Here side AE is also equals to x plus y. Okay, side AE is also equals to x plus y. Then I copied the big triangle ABE in this page, and we analyze triangle ABE. This is triangle ABE that I copied from the original drawing. It is given as the equation that this angle equals to theta, that is the angle that we are looking for. It is given as the equation that side AB equals to x plus y, and we just right now found out that side AE equals to x plus y. And we have already found out that angle AEB, this angle equals to 20 degrees. So here we have an associated triangle. Why? Because those two sides are both equal to x plus y, therefore they are equal to each other. That is to say, side AB equals to side AE. Because of the fact that they are both equal to x plus y, they are equal to each other. So we know that side AB equals to side AE. And according to the rule that in front of equal sides in the triangle there are equal angles. So in front of this angle, angle AB, we have 20 degrees. In front of this angle, in front of this side, side AB, we have 20 degrees. In front of this side, side AE, we have theta. And according to the rule that I mentioned, those two angles must be equal to each other. Why? Because they are located in front of equal sides. That is to say, angle theta equals to 20 degrees. So the answer to the question that angle theta equals to 20 degrees. We finished in the first method. In the next step, I actually presented to you the second method. In the second method, we didn't do any constructions, but here we focused on triangle ADC. In triangle ADC, this angle equals to 80 degrees. This angle equals to 40 degrees. So the sum of those two angles is 80 degrees plus 40 degrees is 120 degrees. So if the sum of those two angles is 120 degrees, it means that this angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle ADC to 180 degrees. This angle must be equal to 60 degrees because 60 degrees plus 120 degrees is 180 degrees. So this angle equals to 60 degrees. Then we define this side AD as A, and then I presented to you the law of cosines, and we implemented the law of cosines in triangle ADC and also in triangle ADB. So what is the law of cosines? The law of cosines is true in any triangle. So here we have triangle ABC that could be any triangle. The length of side AB is C units, the length of side AB is B units, and side BC equals to A units in its length. And so according to the law of cosines that is true in any triangle, here A over sinus A equals to B over sinus B equals to C over sinus C. Here capital A is the size of this angle, angle BAC. Capital B is the size of this angle, angle ACB, and capital B is the size of this angle, angle ABC. Okay, while small a, small b, and small c are the lengths of the sides of triangle ABC. Okay, so according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Then we implemented the law of sines in triangle ADC. So here in triangle ADC, this triangle, in this triangle ADC, we will get that DC over sinus 60 degrees equals to AC over sinus 80 degrees, and it is equal to also AD over sinus 40 degrees. Okay, so I repeat again, in triangle ADC, DC over sinus 60 degrees equals to AD over sinus 40 degrees equals to AC over sinus 80 degrees. Here, DC equals to X, so we substitute DC by X. AD equals to A, so we substitute AD by A. And AC equals to Y, so we substitute AC by Y, and we got this equation. And because of the fact that we have three expressions that are all equal to each other, we can define the value of the three expressions as K. So we can add here that those three expressions, they are all equal to K. Okay, so we have here the Lorenz equation number 1. From the Lorenz equation number 1, we derive that this expression equals to K, that is to say X over sinus 60 degrees equals to K. Then multiply this equation number 1 by sinus 60 degrees, and found out that X equals to K times sinus 60 degrees according to equation number 1. Then those two expressions are equal to each other, or this expression also equals to K. So we can write down that according to equation number 2, A over sinus 40 degrees equals to K. Here we multiply this equation number 2 by sinus 40 degrees, and we found out that A equals to K times sinus 40 degrees. And finally, this expression also equals to K. So we get an equation number 3 that states that Y over sinus 80 degrees equals to K. Then we multiply this equation number 3 by sinus 80 degrees, and we found out that Y equals to K times sinus 80 degrees. Okay, so we have three expressions for A, X, and Y. Okay, then we have here ABC is a triangle. Side BC is one side of triangle ABC, therefore it is absolutely a straight line. So we can write down that BC is a straight line. So if we focus on the upper side of the straight line BC at point D, then on the upper side of BC at point D, you know that the sum of the angles must be equal to 180 degrees. So which angles we have here? We have this angle that is equal to 80 degrees plus angle ADB. In total, the sum of those two angles must be equal to 180 degrees. So 80 degrees plus angle ADB must be equal to 180 degrees. We subtracted 80 degrees from this equation and found out that the missing angle ADB equals to 180 degrees minus 80 degrees. It is equal to 100 degrees. So this angle equals to 100 degrees. Okay. Then we focused on triangle ADB, and we implemented the law of sines in this triangle ADB. According to the law of sines, we get that AD over sinus theta equals to AB over sinus 100 degrees. Again, AD over sinus theta equals to AB over sinus 100 degrees. I'll repeat again. In triangle ADB, AD over sinus theta equals to AB over sinus 100 degrees. Okay, here AD equals to A, therefore I substituted AD by A, and AB equals to X plus Y. So we substituted AB by x plus y. Okay, we substituted AB by x plus y. So in conclusion, according to equation number 2, we found out that A over sinus theta equals to x plus y over sinus 100 degrees. Then we substituted A by k times sinus, here we substituted A by k times sinus 40 degrees. We substituted y by k times sinus 40 degrees. And we substituted x by k times sinus 60 degrees in this equation, equation number 2. And we got this expression. In this expression, we have k on both sides of the equation, so k will get cancelled. And what is left from equation number 2 after we cancel k? What is left is that sinus theta, sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Here we cross multiply this equation, equation number 2, and found out that sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. Then we divided this equation, equation number 2, by sinus 60 degrees plus sinus 80 degrees, and found out that according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Okay, then we used the following trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta. We use this trigonometric identity for sinus 100 degrees. Sinus 100 degrees equals to sinus 90 degrees plus 10 degrees. And according to this trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta, we'll get that sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. Okay, so I actually found out that in conclusion that sinus 100 degrees equals to cosine 10 degrees. So we can substitute sinus 100 degrees by cosine 10 degrees. Then we have the second trigonometric identity that states that sinus 2a equals to 2 sine a cosine a. According to this trigonometric identity, we found the value of sinus 40 degrees, but actually sinus 40 degrees equals to sinus 2 times 20 degrees. And according to this trigonometric identity, sinus 2 times 20 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. That is to say, we can substitute sinus 40 degrees in equation number 2 by 2 times sinus 20 degrees times cosine 20 degrees. We did it, and we got here that here, instead of sinus 40 degrees in equation number 2, we wrote down 2 sine 20 degrees times cosine 20 degrees, and instead of sinus 100 degrees in equation number 2, we wrote down cosine 10 degrees because we already found out that cosine 10 degrees equals to sinus 100 degrees. And all divided by sinus 80 degrees plus sinus 60 degrees. And we have another trigonometric identity that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. Okay, so here, according to this trigonometric identity, we'll get that sinus 80 degrees plus sinus 60 degrees equals to 2 times sine d plus c is 80 degrees plus 60 degrees is 140 degrees, and 140 degrees over 2 is 70 degrees, times cosine d minus c over 2. D minus c is 80 degrees minus 60 degrees, that is 20 degrees, and 20 degrees over 2 is 10 degrees. So here In conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. So in conclusion, we can substitute sine 80 degrees plus sine 60 degrees by 2 times sine 70 degrees times cosine 10 degrees. Actually, we did it and we got that. In conclusion, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees, and we substituted sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. So here we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. And finally, we found out that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. Okay, so we actually have trigonometric identity for sinus 70 degrees according to the following trigonometric identity. Sinus 90 degrees minus theta equals to cosine theta. Therefore, sinus 70 degrees, that is equal to sinus 90 degrees minus 20 degrees. Here, sinus 90 degrees minus 20 degrees, according to the trigonometric identity, that sinus 90 degrees minus theta equals to cosine theta. Therefore, sinus 90 degrees minus 20 degrees will be equal to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we can substitute sine 70 degrees in equation number 2 by cosine 20 degrees. We did it, and we got here that sinus theta equals to sinus 20 degrees times cosine 20 degrees over sine 70 degrees, but we just right now found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we substituted sinus 70 degrees by cosine 20 degrees here in equation number 2. So we have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator. So cosine 20 degrees will get cancelled, and finally we found out that sinus theta equals to sinus 20 degrees. And we know that if sinus A equals to sinus B, it means that A equals to B, or sinus alpha equals to sinus beta, it means that alpha equals to beta. So we know that sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in both methods, we found out that the size of angle theta is equal to 20 degrees. Here, the size of this angle theta, this is also angle ABC, it is equal to 20 degrees in both methods. Okay, thank you very much.